Sathyabama Institute of Science and Technology.
Hello everyone, I am Pothumani, Assistant Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. Today's topic is Introduction to Hadoop. Hadoop is one of the famous big data analytical tool. It is open source software framework which is going to allow the distributed processing of large data sets. So here the large data sets are available in the different clusters of the computer using the simple programming models. So Hadoop is a scalable one which is going to support single servers to multiple machines, several machines. Then what is the aim of the Hadoop means, which is used to handle increasing the data processing and storage demands in the digital age. So introduction to Hadoop. Hadoop was created by Doug Cutting and Mike Caffarilla, who were inspired by the Google's MapReduce and Google file system. The name was chosen by Cutting's son's toy elephant. The Hadoop is fully written in Java. And these are the features of Hadoop. First one, scalable. So the Hadoop is going to support large machines, large set of machines. It may be single system or single system to several machines. Second one is reliable. Reliable is nothing but the data will be replicated. So we are going to store more number of copies of data. So automatically if one machine fails means we have a set of copies in the other machines also. So Hadoop ensure the reliability of the system. The next one, flexible. As you know that in big data analytics, we are going to support different format of data. The format of data may be structured data, unstructured data or semi-structured data. So what kind of format you are going to provide, that will be supported by the Hadoop environment. The next one is cost effective. Then these are the core components of Hadoop. First one, Hadoop Yarn. Second one, HDFS. HDFS is nothing but Hadoop distributed file system. Third one, MapReduce. Last one, common utilities. Hadoop distributed file system, HDFS. This is the storage layer of the Hadoop. So which is going to store large files across the multiple machines. So the particular large file will be broken into smaller chunks, smaller blocks. The block size may be varied from 128 MB to 256 MB. So the 128 MB to 256 depend upon the requirement of the user, the block size will be varied. So these smaller blocks are going to distribute to the different clusters. So which is going to ensure the reliability with the help of the redundancy of data. Then rack also used for collection of nodes. So this is the overall architecture of the HDFS. So there are two main components are there. One is the name node, another one is the data node. Name node is used as a or act as a master node which is going to collect all the information about the data node. How the particular file will be separated into smaller blocks, what is the block is stored in which data node, all the details will be collected by the name node, and depend upon the name nodes instruction only data node is going to work. Here number of data nodes are available that will be collected in the different types of racks. So this is the working principle of the name node. So act as a master, manages all the file system namespaces which is going to store the metadata. Metadata is nothing but data about the data. What is the file name, how the particular file is divided into smaller blocks, where the particular block is stored, which data node store all the data, everything will be considered as metadata here, and which is going to regulate the file access by the client also. So the name node is going to keeps a record of all the files in the file system, and it will get the heartbeat from the data node also. What is meant by heartbeat means every 3 milliseconds the data node is going to send a particular message to the name node whether it is alive or not. So it will check the heartbeat from the data node also. So the data node, what is the work of the data node means, the major work of the data node is going to store the data. So the data node store the different large files into smaller blocks here. So this is act like a worker node, store the data, and which will perform the read and write requests from the client and responsible for block creation, deletion and replication. How it is going to create the block means, suppose your file size is 200 MB means we are supporting 128 MB for a particular block means the block will be divided into the 200 MB will be divided into two blocks. One is 128 MB, another one is 72 MB. So two blocks are created as per the instruction given by the name node. Second one, block deletion. This is also instruction given by the name node. Third one, replication. Replication will be decided with the help of the replication factor. The default replication factor is 3. Suppose here we are creating two different type of blocks here. So these two different blocks, that is two blocks into replication factor is 3. So 2 into 3, 6. So 6 copies of data will be available in the entire Hadoop system. Then it sends the heartbeats to the name node periodically. That is every 3 seconds data node is responsible to sending the heartbeat to the name node. Then the next component, MapReduce. MapReduce is the processing layer of the Hadoop. This is also Java based and working in the distributed environment, which is going to process the large data set. So the tasks are divided into smaller chunks, that is smaller fragments. The fragments are nothing but which is going to process in the parallel manner across the Hadoop cluster. There are two major steps in the processing steps. One is a map step, another one is a reduce step. So this is the overall diagram for your MapReduce program. So we are going to get the input. The input will be divided into smaller map function. The tasks are named as map task. Then the results are consolidated with the help of the reduce task. That is with the help of the reducer function. Finally, the output will be consolidated and provide the output to the client. Then components of MapReduce. One is a job tracker, another one is a task tracker. Generally, job tracker will act like a master. Master is nothing but a background process, that is daemon process, run in the name node of the master system. Then which is going to submit and track the MapReduce jobs for each and every task tracker in the particular Hadoop. So what is the work of the job tracker means, which is going to assign the task to the different task tracker. So it manage all the resources and schedule each and every map on the task tracker also. And what is the work of the task tracker means, it is act like a slave node. What is the instruction given by the job tracker, that will be done by the task tracker here, which is going to execute the map and reduce task. And this is a small example for how the MapReduce is performing. So we have the input. Input is nothing but here we are going to do the word count. So input is a sentence. So welcome to Hadoop class, welcome to Hadoop class, Hadoop is good, Hadoop is bad. So 3 sentences are there. So we are going to count the words available in the sentence with the help of the map and reduce task. So first we are going to split the inputs. First one, welcome to Hadoop. Second split up is class Hadoop is. Third one is good Hadoop is. The last one is bad. Then how it is going to mapping means, how many times welcome is appeared in the welcome to Hadoop. So welcome is 1 and 2 1. Hadoop 1, then class 1, Hadoop 1, is 1. Like that we are going to map the jobs here. Then in between the mapping and reducer, we have the shuffling phase, which is going to group the different type of words here. So bad 1, class 1, here good 1, Hadoop 3 times occurred in the particular paragraph. So Hadoop 1, 1, 1, collected from the different map task. Then is 2 times occurred, that is 1 collected from the different map task. Same thing 2, 1 and welcome 1. Finally, the reducer is going to reduce everything, that is bad 1, class 1, good 1, Hadoop 3 times it occurred, so Hadoop 3, then is 2 times occurred, so is 2, then 2 and welcome is 1 times occurred. So finally, we are getting the word count for the particular input. The next component is yarn. Yarn is yet another resource negotiator. So already we saw how to store the data in the Hadoop, how to process the data in the Hadoop. So how you are going to allot the resources? We are going to allot the resources with the help of the yarn only. Yarn is act as a resource allocator for the entire Hadoop systems. So number of systems are there, number of applications are there. How we are going to allocate the resources? So first one, the major work of the yarn is to separate the resource management layer and the processing layer. and allows the different data processing, like your data processing may be batch processing or stream processing, interactive processing or graph processing. So we are going to support all the different type of data processing. And this is the overall architecture of the yarn. So there are two different clients are there, and one resource manager is there, and three different nodes are there. So first, the components of the yarn is resource manager and node manager. Resource manager will act like a master which is going to manage the resources and also which is going to schedule the applications. So depend upon the client request, it is going to schedule the applications. And what are the components of resource manager means? One is the scheduler, another one is the application manager. Here, what is the work of the application manager means? It will handle all the job submissions and complete the job and then provide the output to the resource manager. And scheduler, which is going to allot the schedule for the application. In that, the scheduler is available in the resource manager system itself, and application manager is available in each and every nodes of the slave system. So the node manager will act like a slave system. So what are the instructions are given by the resource manager, it is going to do that, and which is going to manage the container. So in the slave systems, node manager is there, application manager is there, and container is there. Container is nothing but collection of physical resources like CPU cores, otherwise RAM, ROM, depend upon the user, the container will provide the resources here. So monitoring the resource utilization and tracks the node health, whether the node is capable to handle these type of requests or not, and how to maintain the log file, that is log management, and communicates with the resource manager. These are all done by the node manager. And first, the client is going to submit the request to the resource manager. Resource manager will schedule for the application manager. Application manager is accepting the jobs and negotiate the containers. Node manager is going to provide the node status to the resource manager, and containers are going to allot to the application manager, and they are providing the results for the map and reduce task. And Hadoop Common, this is the last component of the Hadoop architecture. So it will provide only Java libraries and utilities. So these component is used to facilitate the other components of the Hadoop to work together effectively. Thank you.